As a math educator, I want to challenge Richard Murphy's video on the relationship between GDP and life expectancy. I'm concerned that he may have said things misleading to those who have not studied math and science. Mr. Murphy contrasts these two graphs in a way that may give viewers the impression that the left side is mathematical sleight of hand. They both graph the same data. The left side uses logarithmic scale, the right side uses a linear scale. Logarithmic graphs are valid tools regularly used by mathematicians, engineers, and physicists. So we need to ask, does Mr. Murphy have a valid concern? Should we reject the log graph in favor of the linear graph? Yes, Murphy is correct, but he could have clarified better. Why is he correct? Because the log graph motivates the wrong question. The log graph suggests we assume a simple correlation between GDP and life expectancy. But we really want to ask, what is the threshold for a normal lifespan? Where does the curve plateau? The log graph motivates the wrong question. The linear scaled graph motivates a better question. Why does the linear graph motivate the better question? Low life expectancy is usually caused by preventable illnesses, contaminated water, war, famine, and other poverty-related problems. We want to determine how much funding does it require to control most of these problems. The answer appears to be surprisingly low from the perspective of the USA, only about $20,000 per citizen. But that is not the only question we should ask. We should ask about the spread, the outliers. Why is Japan above the curve? Why is the United States so far below the curve? Perhaps there would be a better way to graph this. That's right. Use the log scale graph. The log scale makes it easier to see the outliers. This plot does not answer the questions, it motivates the questions we need to ask. Which countries beat the trend? The countries above the green line. Why do they beat the trend? Which countries underperform? The countries below the red line. The log scale doesn't answer these questions, it reminds us to ask these questions. We use data to test our hypotheses. Can we identify a trend or a correlation? Do we see a threshold value or a tipping point? But we must also use data to motivate more questions. Is the correlation tight or too wide to be useful? How wide is the spread? What do the outliers teach us? Mr. Murphy introduced a concept, but may have made misleading comments about the graph. I hope my video clarifies the graphs for you. I hope it encourages you to think deeper, ask more questions, and seek more data to answer those questions.